channel.
Okay, welcome, Catherine, Genevieve, and Yejin and Jacqueline. This is the week 7 webinar. And there's a lot of things I'm going to talk about today. Let me share my screen and then I'll go over the agenda.
Yeah.
So the plan today is I'll start out with Q&A if you have it. And then after that, we'll talk about hypothesis testing. And I'll let you know, that's what we'll be talking about pretty much every single day for the rest of this entire quarter is hypothesis testing. So today we'll get into the idea of hypothesis testing first, what it's about, and then we'll get into details. So we'll talk about what is a hypothesis test for a proportion. I'll get into type 1 and type 2 errors. And then we'll interpret the p-value. And then we'll interpret the level of significance. Then we'll talk about the hypothesis test for a mean. And that's kind of a big thing this quarter is that there's means and there's proportions. Those are the two biggies. And most of the class is on one of those two things. And then I'll spend a little time talking about the project. I'm not going to get into everything about it because we don't have quite the material yet, but we can start thinking about it. So that is our plan. So let me ask you, are there any questions about anything? And I guess I should give you a little warning. There's a chance that my office hours won't work on Wednesday. I don't know yet, but I just got this on my door. Now you probably can't see it, but what it says is Liberty Utilities has arranged for the electric system improvements in your area. An outage has been planned from 10:28 8 a.m. to 4 p.m. I'm screwed. So there's a chance that I can go somewhere else. There's a house that I might be able to get to in Sacramento. I'm going to plead to the college to let me in. But if I'm not in my office hours on Wednesday, that's because I have no electricity and I'm sitting here, not in the dark because it'll be daytime, but without the ability to be on the computer all the time. So just a note, apologize in advance, but hopefully I'll get it set up. But I figured I should mention it just in case. So any questions about anything at all? Again, this is your chance. Webinars are the perfect time to ask questions. Any questions? Okay, if there's no questions, let me talk about hypothesis testing and kind of compare hypothesis testing to confidence intervals, because we've been spending the week on confidence intervals last week, and now we're going to move on. So confidence intervals, but the idea of a confidence interval is that you conduct a survey, or collect data, and you don't know the population. So what you do is you say, well, how close am I? And you say, well, somewhere between here and there. Okay, and at that point you say, well, maybe 95% is not the best. Let's try 90%. Maybe that'll be better for me. You could look at that. Okay, so that's what confidence intervals are kind of about, is just give you an estimate. Hypothesis tests are different. Hypothesis tests are not about giving an estimate. Hypothesis tests are about making decisions. So for example, any of you ever been in a court where you had to be on a jury? I had to once. Do you make a decision, or do you say, well, it's kind of close to this? What do you think if you're in court? Never got picked, okay? Well, I'll tell you, you make a decision. It's either guilty or not guilty, okay? And it's not quite even that. It's really guilty or there isn't enough evidence to convict the person. And I'll give you an example. My one example is that I had to make that decision. And actually, they put me as a foreman of the jury just because, I don't know, because I was talking a lot or something. And we had to decide whether this woman was involved in this big meth deal. And as a group, she probably was. She might have been, but they didn't have evidence to show that she was involved in this meth deal, even though she might have been. Okay, she had some history of it, but they didn't have evidence. So we did not find her not guilty. We just didn't have enough evidence to say she was guilty. Do you see the difference between those two? And this is a big, big piece of what we're doing today. Is we're not gonna say yes. We're either gonna say yes, we have evidence to say this, or we're gonna say we don't have evidence to say anything. We're never gonna say no. Any questions on that idea first? Okay, I let you know this fancy word hypothesis testing. You have seen what it does, just you might have used different words because it's common curriculum, at least in America. I have no idea about China. But it's common curriculum in America, but it's called something different. It's called the scientific method. Do you remember that? You learn it in high school, sometimes middle school too. Do you remember the scientific method? So who remembers that? You should all be jumping in and tell me. Either you do or you don't. Sort of. Yeah, again, you were children when you were doing it. I have no idea how old you are now, but could have been a while. You don't, okay? But it did happen. It's part of the curriculum, standard curriculum in school. So you've maybe heard of it. At least one person's maybe heard of it. One doesn't remember. Old. Okay, but it did happen. Even old people. I'm an old person and I got it too. So I'll let you know, the scientific method, I'll tell you what happens, and it's the same as hypothesis testing, and it's a step-by-step process. But I'm going to call it hypothesis testing because that's what we call it in statistics. And it's very much step-by-step. It's not like you can do these steps. These are the orders you have to do them. And I think I'm too big here. That's better. So the first test is come up with an idea. That idea we call hypothesis. Okay, so here's an example. And I'm bringing this up because this is what everyone's talking about at least these few weeks. And what's coming up in a couple weeks? Actually, 1 week, week from tomorrow. There's Thanksgiving, but what's happening a week from tomorrow? Thanksgiving's a whole month. Yeah, election day. Okay. So I want to come up with a hypothesis. So here's the thought. I kind of know California. California is voting Biden. Okay, I'm being recorded. California is voting Biden. It's just that's just a done deal. But I don't know about y'all, but I'm in Tahoe right now, and we are a kind of a bi-state area, and Nevada, on the other hand, is a whole different situation. So my hypothesis is that Biden will win in Nevada. Any questions on that? Okay, so that's my first statement. Okay, the next is to write down the hypotheses formally. And we're going to call these the null hypothesis and the alternative hypothesis. Okay, so to write those down formally, this is where you're going to have to just do it the way I do it. Okay, this is the way everyone does it, and it's the following. We're gonna use H for hypothesis. It's capital H, sub 0. And the British got to it before the Americans. How do you say 0 in British? Now Z is Z. Good try though. Yeah, Z is how you say Z in British, but it's definitely a weird word that we don't use in English in America. But how do you say 0? If you don't know, I'll tell you. Not. N-A-U-G-H-T. Okay. So H naught is the way everyone pronounces this guy. Then you put a colon. Very important that you put a colon. Do not put an equal sign after H naught, or I will take off points. So H naught. Then what you do is you think about, well, what kind of data am I going to get here? Am I going to be getting a bunch of yeses and nos, or am I going to be getting a bunch of numbers when I conduct my survey? What do you think? And that's kind of a big theme of this whole class. It happened last week too. Yeah, these are yeses and nos. Now, what letter did we use when you have a bunch of yeses or nos to talk about the population? Who remembers the letter? It's not a trick question or anything. Same as last week. Do you see? Do you remember? It's one letter. It doesn't take long to type in. Z, good try, but that's definitely not the yeses or nos. So let me write it down and you'll say, of course, I think. P. P for the proportion of, right? Remember when we talked about confidence intervals, it was P lies between these two numbers, as in the proportion of yeses. Okay, and in fact, P comes up a lot in our class. So P, then you go equals. Okay, now if Biden does not win, what's the best he could do by not winning and still not win? What proportion? It's not a trick question. Yeah, 0.5. So H naught is going to be that P is equal to 0.5 because that means he didn't win, and it's kind of the highest number he could have and still not win. Okay, just let you know, H naught, that's the null hypothesis. Then we're going to do the alternative hypothesis. We're still going to use H for hypothesis. And now there's actually two different notations you'll see. Sometimes you'll see H1. Sometimes you'll see HA. I'll just use H1. I'll probably go back and forth. And sorry about that. I'd rather have everyone agree with the same number or letter or whatever, but they don't. So depending on the book, depending on literature, you'll see something different every day. So H1, but it'll either be H1 or HA. So H1 as in 0 and 1, kind of the other side of 0, and or HA, A for alternative. And that's what you'll see. And then you'll see a colon, not an equal sign. You never have an H equals. And then we always write the same thing, P. And now if Biden wins, what does that tell you about P? Not 1. No one gets a P equals 1. I can guarantee that's not happening in Nevada. That means 100% of the people in Nevada are going to vote Biden. Yeah, greater than 0.5. So P is going to be greater than 0.5, and that's what you need to win the election. And as I mentioned, not 0.51, because when I ran for office the first time, I got it was about 0.502 or something like that. It was ridiculously close to 0.5, and I still won because I was over 0.5. So again, there is no rounding. It's over 50%, anything over 50%. Any questions on this notation? Any questions on the notation? Okay, so just let you know, this notation is sticking with us pretty much for the rest of this quarter. You need to understand that if you want the null hypothesis and alternative hypothesis, you're going to write H naught with a colon and stuff. You can have an H1 with a colon and stuff. Okay, with the H naught, it's always going to be an equal. With an H1, it could be a greater than. What else might it be? What might else you hypothesize besides greater than 0.5? The hint is I could change one word and that would change the H1. Here's the word. What if I change that to lose? Yeah, then it would be a less than instead of greater than. Okay. But I'm going to let you know of another one that comes up, right? If Biden loses, that means he gets less than 50%. Do you see? Okay, less than or equal to, but usually write less than. Because remember, in statistics, equal isn't an issue because we're assuming everything's normal and then it's continuous and equal doesn't matter. So I write greater than. And that's standard. Okay. But there's another possibility. You could have less than, you could have greater than. What's the other thing you can have that kind of is another thing besides equal, the other side of the coin? Any ideas? Okay, you could have not equal to. And what that means is it's not a toss-up. Okay, you probably wouldn't do that too much with elections, but the not equal to happens, especially when we're going to do with means. So for example, if, and I know very little about medicine, but maybe you guys know, I think some of you, I know some of the group is studying it. What is a good heartbeat? Throw a number out at me. I don't care if it's right. What's a good heart rate? 74. Okay. Okay, I'm going to go with 74. So the idea is, let's say 74 is healthy. Then if you're 40 for your heartbeat, that's not good, is it? If you're 160, really bad. You're probably going to die either way. So that would be a not equal to you care about, because if you want to find out if the person's healthy, then you want that heart rate really close to the 74. Okay. And if it's far from the 74, then that person needs help, medical help. So that would be a case where not equal to would matter. Any questions on that idea? And as a medical profession, you deal with the not equal to. Okay, so we just looked at step 2, and I will let you know that I use P here, but that's because it was yes or no. If it's not yes or no, what if the survey question instead of asking if Biden's going to win, let's suppose you looked at heart rates. You don't use P here because P, it's not a yes or no question. Well, what letter would you use? What letter do we use if you're talking about quantitative data? And the hint is you can't type it. You can only type the word of the letter, but not the letter. So what letter would you use if you're talking about heart rate, quantitative data? P hat still the yes or no. P hat is a sample proportion. You all know this. If you're talking about quantitative data, what letter do we use? All right. If you don't remember, I'll tell you. X bar is a good idea. And that you're onto something, but not quite right, because X bar is a sample mean. And the hypothesis, and I'm glad you brought this up, The hypothesis is never about the sample, just like the confidence interval is never about the sample. It's about the population. Okay, and by the way, I noticed, who remembers the secret word from last week? All. I want to let you know something. I graded your discussion post assignments today. 3/4 of you, I think at least, maybe more, when talking about the confidence interval, didn't use the word all, and I took a point off, or a half a point. Okay, and I promised I would. I said, this is why we're doing a secret word. So pay attention to the secret word. Okay, and it's, you know, the word all being important is not secret. But it's very important that when you're talking about a confidence interval or hypothesis test, you're talking about all, not the sample. You're talking about the population. Any questions on that idea? And you must state it, that you're talking about the population. And the word all usually does that when you're talking about proportions. When you talk about means, you always use the word population. Okay, so let me go to step 3. I'm going to type it out, and it won't mean anything to you until I talk about it. And that is analyze the repercussions of a type 1 and a type 2 error. All right, so the first thing is I want to mention something, because I've learned that a lot of people don't know the English word. It's not a math word. Repercussions. What does repercussions mean? When I first started teaching, I thought everyone knew the word. I was wrong. Now I've learned I got to teach this word, even though it's not a math word. Yeah, the consequences, the bad stuff that's going to happen because if it happens. Okay, and that's what we want to look at. So notice a key word here, error. Error is not a good thing. You don't want an error. You want to get it right. So type 1 and type 2 errors are when you got it, when you didn't get it right. So let me define a type 1 error. So a type 1 error means that you rejected H naught, the null hypothesis, you accepted the alternative hypothesis, but the null hypothesis is actually correct. Any questions on that? Okay, let's take a look at the type 1 error for this example. Okay, and then I'll give you some more examples that are more severe. All right, so this example, that means that you accepted that P is greater than 0.5. That means you're accepting, you decided Biden's got it. He's a shoo-in. He's winning in Nevada, period. He's done. Okay? So what are the repercussions of a type 1 error? What bad things are going to happen if you accepted that Biden's going to win, but Biden does not have over 50% of the votes right now, or the voters, you know, wanting to vote for him. He loses, but let me explain what really happens, and I'll tell you as a politician, okay, because I've been through this. If you decide if I decided, in fact, in my second election, I decided I was going to win. I was able to fully reject the null hypothesis, and I knew I was going to win. Okay. And I told the people who were going to support me that there's no reason to spend money on my campaign. You're wasting your money. I'd rather you just give to a scholarship for kids, because it was a, you know, unified district kid thing. All right. Well, had I had a type 1 error, then I would have told them not to even bother spending money on my campaign. But guess what? I didn't have the 50%. And had they spent the money on my campaign, maybe people would have been convinced to vote for me, but they ended up not because they didn't spend money, and I would have lost. Do you see that? Whereas if I decided I didn't quite have the 50% yet, then I would have asked them to put money into my campaign so that I can raise that percent up. Because right now we only have the pre-voters. We don't have, they haven't voted yet. Actually, I voted yesterday. I dropped my ballot in the slot in grocery outlet, believe it or not. So I voted yesterday, but most people haven't voted yet. So you do, want to think about advertising. And if you've decided Biden's going to win, there's no reason to fund Biden's election because he's got it. Do you see? And that would be bad, right? It'd be bad for Biden because he thinks he's going to win, doesn't bother spending a lot of effort in Nevada, doesn't come to Nevada, give a speech, doesn't send out mailers or all the other things that politicians do, and then he loses the election. Any questions on that idea? And that's pretty bad. Okay, but then there's a type 2 error. So type 2 error means that you failed to reject the null hypothesis. But the alternative hypothesis really was true. Okay, so I want to mention something that's really important. Never, ever, ever accept the null hypothesis. That is not something you do in statistics. You fail to reject. I know it looks like a double negative, but it means that we don't have evidence to say the null hypothesis is false, which is not the same thing as saying the null hypothesis is true. It might be the sample size is too small, for example. And the null hypothesis is true, but the sample size is too small. We don't have anything to say. So just let you know that that could happen. All right, so in this case, in a type 2 error, that means that we didn't think Biden was really, we didn't think Biden had it. Okay. He didn't have over 50%. So we're going to spend a whole lot of money getting that campaign going. Biden is going to come to Nevada and cheer up the crowds, right? Spend $1 million in Nevada on mailers and other things. But Biden was going to win anyway in Nevada. And what the big repercussion is he might lose in, say, Pittsburgh because he went to Nevada instead. He didn't have time to go to Pittsburgh, and he could lose the election just because he was able to went from maybe 54% to 70%. Doesn't make any difference whether you're 54% or 70% in Nevada, because you still get all the you get all of the electorate. So that would be pretty bad. Any questions on that? Which is worse? Type 1 or type 2 in this case? If you were Biden's campaign manager, which do you think is worse? Or are they equal? So step 4 is decide which is worse, the type 1 error or type 2 error. Okay. And now there's going to be 3 possibilities. First, if it's type 1 is worse. And in our class, this is what we're going to do. It's a little more complicated than this one in advanced statistics, but for elementary stats, we can get away with this. is we're going to use a level of significance. So if the type 1 is worse, then you want to make sure that you don't have a type 1 error. So then we're going to use a level of significance of 0.01. So B, type 2 is worse. And then we're going to use a level of significance of 0.1. And then C is they're about the same. And then you use a level of significance of 0.05. Okay, and I didn't put it originally in here, but I want to now. I didn't want to scare you, but now it's time to scare you a bit. We use a Greek letter for level of significance. And let's see if you know, it's the first Greek letter of the alphabet. Anyone know? See, when I was a kid, everyone knew because it was a grocery store. It was called Alpha Beta. And it's alpha. So level of significance letter is alpha. And it's kind of like somewhat like the opposite of a confidence interval. A confidence interval is kind of a chance that the confidence level, I mean, it's kind of the chance that you got it right. If you're 95% confident, that's kind of like that means that if you're 95, if you're using a level of confidence of 95%, before you start, there's a 95% chance that the population proportion is going to be in your interval. Once you've actually selected the interview, things change. But before you start, you can say that. Similarly, alpha is the chance of having an error before you start. So this is going to be the chance that we're going to have a type 1 error if we end up with, if the null hypothesis is true, it's a probability you're going to end up with a type 1 error. Okay, so just let you know, type 2 error is a little more complicated, but that's kind of a chance, it's a probability of a type 1 error before you start. Okay, and I want to note that 1, 2, 3, 4, I'm on number 4 right now. The order is necessary. You cannot change the order. Step 5. Step 5 is collect the data. So you can never, ever, ever write your hypothesis after you've collected your data. Okay, that's actually wrong. Any questions on that? And you should never, ever decide on your alpha after you've collected your data. Okay, this order matters. Okay, number 6. So now after you collect your data, then you're going to compute the p-value. And this is one of the unfortunate things about statistics. The letter P is used for so many different things. This is different than the P in the hypothesis test with the proportion. Okay, sorry about that. Don't get mad at me. It's just what everyone uses. And so I got to use it. So the p-value, oops. The p-value is the probability that if H naught is true, And if you did another study, the same sample size, then you would get as extreme or more extreme results as what you got in your study. And it changed pages, so let me fix that a little bit. That might do it. Okay. So I know that's kind of abstract, but it tells you how unlikely your data is had H not been true. So let me give you a simple example. If I flip a coin 100 times and I get 99 heads, what would you say? And let's say we were playing a game, and every time I get a head, I get $1 from you. What would you say? If I flipped a coin 100 times and I got 99 heads and 1 tail. Yeah, you would say I'm cheating. And you would say I'm cheating because the probability of that happening, if I'm not cheating, is so small that you're going to say I'm cheating. Do you see that? What if I got 51 heads? Would you say I'm cheating? No, because you'd say, you got a little bit bad luck, but nah, that's not too surprising, right? The p-value is how surprising the outcome is. Okay, it's that probability of that outcome happening. Okay, and the 99 heads means 99 or 100, right? 99 or more heads. Do you see how that works? And that would be a hypothesis test. Is your H naught would be P equals 0.5. H1 is P is greater than 0.5. You want to test to see if I'm cheating. And then you'd end up with, if I got 99 heads, then you would reject the null hypothesis and say, yes, he's cheating. Any questions on that idea? Okay, let me give you another example. And this is a true example. And it's a true, kind of pretty stunning example. And this happened in Africa. Okay, unlike the rest of the world, what are the Africans really worried about in terms of diseases? Do you know? I know you're not all from Africa, but you might know a little bit. What's their bad disease? One of the bad ones they get. Yeah, AIDS. So what they wanted to do is they wanted to find out if circumcision helped reduce the chance of getting AIDS. Okay, you guys know what circumcision is? Okay, yeah. Okay, the guys don't want to answer because it's like it just hurts to think about it, right? But the problem is if it reduces your chance to get AIDS, and you're a man, if you're a woman, it doesn't matter because you can't get circumcised if you're a woman. Would you go for it? Probably, right? So they actually did a test, and they did a trial, and they did a study of, I don't remember what the sample size was. And they actually stopped the study because it was so obvious. The p-value was so small. They found out that circumcision actually strongly reduces the chance of getting AIDS. And they made it in Africa not a requirement because you can't require people to get circumcised, but it was actually a suggested practice to circumcise men. Okay, and that hurts, by the way, especially as an adult. I guess as a baby too, but babies are babies, I guess. So they found that out. Okay, and I'm not lying. I mean, this happened. It was medical research that happened. Let's talk about type 1 and type 2 error on that one. What are the repercussions of a type 1 error on that study? So what are the repercussions of a type 1 error on the circumcision for preventing AIDS study? I see y'all jumping in, but it's important. But I like giving this example because it's very easy to remember because it's like you could just picture it in a bad way. Could have not worked. Yeah. So it means that you're going to tell everyone to get circumcised, right? And then you're going to have all these men getting circumcised. And it does nothing. It doesn't help at all. Okay. And that means you're going to have to go through the circumcision if you're in Africa. You're going to have get that little piece cut off. And that is not fun, by the way. Okay. And that's a pretty bad type 1 error. What's a repercussion of a type 2 error? What does that mean? Okay. So what Kevin just said was type 1 error. Hopefully that's what you meant. So multiple circumcisions and thousands, maybe millions, and it doesn't help at all. That's a type 1 error. What about a type 2 error? Anyone know? Maybe I'll jump in. So that, yeah, it works, but then they don't recommend circumcisions because they don't know it works. Okay. They didn't say it didn't work. You don't do that. You just say, we don't really have evidence to show this is helpful. And if you don't have evidence to show that's helpful, no one's going to do it. Okay. You have to be foolish to do that, right? Okay. Or religious, I guess. But as an adult, you got to be foolish. So the point is that you're going to have no one getting circumcised, and you can have lots and lots of people die of AIDS that didn't need to die of AIDS. Okay. Because you could have had a smaller percentage of AIDS in Africa, but you didn't know about the treatment. Any questions on that? Okay. And again, this is a true study. It happened. Right now, the big study they're doing is coronavirus vaccine. Same thing. There's type 1 and type 2 errors, and you got to think about which is worse, how much you have to deal with it. And that one, I can't tell you the data and the results. Do you know why I can't tell you the results? Yeah, it's not in yet. My guess is next quarter when I teach stats. I'll use that as a big example. I hope I'll have a vaccine that actually works, and they had a small enough p-value that they say, yep, this one's good. Okay, that's my dream. Okay, and I really hope it happens, but that's what they're all doing right now. Okay, any questions on kind of number 6, the whole hypothesis testing? Okay, number 7, if P is less than alpha, fail to reject the null hypothesis. Okay, there is not enough evidence. That is, it is statistically insignificant. I'm going to highlight that because that's very important. We're going to be using those words a lot. So if you have a small p-value, then we have statistically insignificant data. On the other hand, if p is greater than alpha, then reject the null hypothesis. And state that there is statistically significant evidence to conclude that the null hypothesis, the alternative hypothesis, is true. And I want to highlight that because it's very important. So again, if we have a p, wait a minute, I have it backwards, sorry. Apologize for that. P is greater than alpha, then you fail to reject. If p is less than alpha, then you reject. The idea is that if you have a very small probability of the null hypothesis being correct, then you say it's incorrect. Whereas if you don't have a very small probability, then you say, I don't know, could be correct, could be incorrect. I don't know anything. So note that if you fail to reject, you just say you say in a fancy way that you know nothing. Whereas if you reject, you actually say you know. I want to mention a word that is not ever in anything we do in this class. And I will take off points in anything you do if you use the word prove. You're not proving the null hypothesis and the alternative hypothesis is true. You are having statistically significant evidence that the null hypothesis is true. It's very different than proving. Any questions on that? Okay, so this is the whole point of hypothesis testing. And this is a step-by-step process. All right, now I wanted to go through this before we do all this stuff. Of those numbers 1 through 7, what's the hardest in the real world? Which part is the hardest by far? Number 1? Nah, number 1, it's like, yeah, it feels good. This is what I think. Yeah, like so small to write it down. This sucker usually takes 100 times more work than everything else combined. Collecting the data is hard. Okay, remember that if you're doing a yes/no question, you got to ask over 1,000 people, and you got to make sure that you've randomly sampled. You know how hard that is. So just let you know, you want to do everything right before you do number 5, because if you mess up on one of them, then you do number 5, you wasted your time, and the time is all on number 5. Okay, not in a like classroom situation when you're just theoretically thinking about it, but in the real world, number 5 is where all the work. Okay, the rest might take a couple hours. Number 5 could take months. Any questions? Okay, so collect the data. So let me show you the data that's collected. So I found this. This was the Pahrump Valley Times. And it says Nevada poll, Trump, Biden virtually tied, but not quite tied. We'll take a look. So they collected some data. And I'm going to massage the data a little bit. And in the real world, you always have to massage data. Just let you know that. Okay. They surveyed 512 likely Nevada voters. Let me highlight that in case you're not seeing what I'm looking at. Okay. From October 7th to 11th, not too long ago. 44% said they choose Biden. 42% said they use Trump. So what I'm going to do to massage the data, there's only 86. I'm going to get rid of the other 14%. Okay, at this point, because we know nothing about them. Let's pretend they don't vote. Okay, I'm also going to do a couple more things. And I'm going to do this because we're not ready to do a better way until next week. And that is, I'm just going to say, does Biden have more than 50% of the decided voters? Well, notice there's 80 that, right? Notice that Biden has more than Trump, and to be decided just means you've decided Biden or Trump. Well, Biden's got 44%. Trump has 42%. Does Biden have more? What do you think? Okay, so it's a trick question. It looks like it's a yes, but this is of only 512 people they asked. Think there's only 512 Nevada voters, likely Nevada voters? No. Okay, Nevada's not a giant state, but there's certainly a lot more than 512. Okay, it's probably a million or so. Okay, so we don't know the population proportion. We really have, we can't know the population proportion, but we have our sample. So what I did, and I did this while before class, so that I was all ready, is I calculated that if you look at the people that supported somebody, Biden or Trump, that Biden had 51.14% of the vote. Does that mean he's going to win? You need over 50%. Does that mean he's going to win? Okay, only if only those 512 people voted. But as I mentioned, that's a sample, not the population. So we don't know yet. So what we're going to do is we're going to do a hypothesis. We're doing a hypothesis test. Okay. And I'm just going to I'm going to say that type 1 and type 2 are somewhat equal. I think that's what we already decided because we looked at those and we now collected the data. Now we can look at the p-value. Okay, so I'm going to go to my calculator and I'm going to look for the hypothesis test for proportion. Any questions on this so far? N it turns out was 440. Remember, there were 512 people they asked, but only 440 of them actually gave a preference. And I'm going to use those people. And X turned out to be, if you take the 0.44 times 512, you got 225. Any questions on that so far? P naught is 0.5. P naught means the null hypothesis number. That's what the naught is for. And then we have to choose less than, greater than, or not equal to. This hypothesis test was a greater than, if you remember. And something you should always do, just make sure that NP and NQ are bigger than 5. And they are. NP is 225, that's X. And NQ is 215, and that's much bigger than 5 also. Because if you don't have that, you can't do anything. Okay, and I hit calculate. So what do you see? Just a note, Z is called the test statistic. I'll often ask you, what is the test statistic? And that's, in this case, it's Z. And it's about 0.4767. And then this P is the p-value, which is about 0.317, 3168, how about? I'll just go 0.3, good enough for me. So now we did the calculation. Again, the calculation is so much easier than the collection of data. That took me, seconds, whereas collection of data would take months for me to do it. Or I'd hire a group of people and it would still take a lot of work. So in our case, the p-value was about equal to 0.3. Now notice that is much bigger than 0.05. Any questions on that? Okay, so if the p-value is bigger than 0.05, what do we do? So it's up there on the screen. That's a hint. Okay, we have a p-value bigger than alpha. Let me give you this word. Yeah, fail. Yeah, definitely the first sentence. It's not statistically significant, it's statistically insignificant. So the conclusion is that there is statistically insignificant evidence to conclude that the percent of all Nevadans, how about Nevada voters, who will vote for Biden is larger than 50%. So what this says is that even though the sample gave more than 50% of the vote for Biden, we're not ready yet. We're not there saying Biden's got it. So guess what? Biden needs to go to Nevada. Biden needs to go and campaign. Okay. And Trump too, by the way. So they need to both campaign in Nevada because they both have a shot there. Do you see? Okay. Right now we know Biden has a shot, but same thing, but it goes both ways in this particular case. Any questions? Any questions on this? So Biden has a shot to win. He also has a shot to lose. We can't say it's over yet. Okay. I don't have the time to do this, but if we did the same thing for California, the p-value would be 0. And it's just obvious at that point. Any questions on this hypothesis test? Okay, let me ask you something. Now that we've made this conclusion, is it the type 1 error or the type 2 error that we have to worry about? Only one of them. Which one? You just put 1 or 2 in your chat box. Which one do we have to worry about now? Yeah, the type 2 error is what we have to worry about because we failed to reject. There was statistically insignificant evidence. That's when you can have a type 2 error. So the type 2 error is the only error now of concern. They were both of concern before we started, but now that we actually have our outcome, it's a type 2 error that's a possibility because we failed to reject. And that means we didn't have enough information to show. So there was not enough information to say Biden's winning. But he is winning. Any questions on that? Okay, type 1 error is not of concern because we didn't reject the null hypothesis. That can't happen. Any questions on that? So once something happens, that changes what you can say about it. Any questions at all about this example and hypothesis testing in general for proportions at least? Any questions? Okay, what I thought I would do, because there was a request for it by more than one of you, is I would go and take a look at maybe a problem that has a mean. So let me go, because some of you said, I'm not, some of you didn't like the fact I'm not showing you what the homework looks like. So I thought maybe I'd do one with the mean. And I'll pop one in, because it's a similar idea with the mean, except we're going to use a mu instead of a p. A few other little things, but it's basically the same. Okay, so let's do it. That's chapter 9, hypothesis test for a single population parameter. And I'm going to go teacher preview, so I'm going to scroll down. You don't get to see it this way, sorry. So let me find one. Okay, how about number 5? Okay, and I may have to go back and forth. Well, I'll be able to do it, actually. The manufacturer claims that your new car gets 23 miles per gallon on the highway. You suspect that the miles per gallon is a different number for your car. The 68 trips on the highway that you took averaged 24.1 miles per gallon. By the way, is that different than 23? Is that different? Yeah, but this is a sample. So you got to be careful about saying, because the sample is different, the population's different. You can't go there yet. We'll find out. And the standard deviation for these 68 trips was 3.3 miles per gallon. What can be concluded at the 5% level of significance? Any questions on the question? Okay. So we're going to use a z-test for a population proportion or a t-test for a population mean. Which one is this? We talking means or proportions? Yeah, this one's means because the survey question is, what was your miles per gallon? And the answer was maybe 25 miles per gallon. So the z-test for population, but it's a t-test for population mean, not a z-test, because we don't know the population standard deviation. We only know the population standard deviation, the standard deviation for these 68 trips. So that makes it a t-test, not a z-test. But it is means, but it's t. Same as confidence interval, is that if you don't know the population proportion, which you almost never do, then it's going to be t, not z. Okay, now let's go to the null hypothesis. H naught. P or mu? P or mu? Yeah, this is mu because, again, it's quantitative data. It's what's your miles per gallon. It's a number, not a yes, no. Less than, not equal to, equal, or greater than. Which one is it? And what's the key? You can read the paragraph again, and there's a key word that tells you. And if you see the keyword, it'll be obvious. So which one? I don't see you all jumping in. All right, let me highlight the keyword. That might help. So which one is it? Keyword is different. Yeah, different means not equal to. Okay, what goes in the next box? Yeah, that's a 23, because we want to find out if it's 23 like you were told, the claim. Okay, H1. This should be easy. Is it P or mu? It's supposed to be easy. Yeah, it's mu. Yeah, you don't switch. It's still quantitative data. Oh, you know what? Sorry, H0 should be equal. I was getting ahead of myself. H1 is a not equal to. I was reading the wrong one. I apologize. And then 23. H0 is always equal. Okay, the test statistic. Is it Z or T? Yeah, this one's T because, again, we already decided we're doing a t-test. Any questions so far? Okay, any questions? Okay, so now what we need to do is we need to go back to our calculator. This is going to be interesting. See if you guys can tell me which number are we going to. Yeah, this is a 14. It's hypothesis test for a mean with statistics. Okay, sigma is unknown. So our S was 3.3, I believe. Let me double check. Yeah, 3.3. Our X bar was 24.1. Our N was 68. Okay. By the way, is our sample size large enough? Yeah. 68 is bigger than 30 because now we're back in quantitative. So yeah. Mu naught was 23. We want to be not equal to, and hit calculate. So let's grab 4 decimals. Might ask for 3. You could always do more on the homework, by the way. Okay, and then let's do the p-value. And the p-value is 0.007681. Just grab a bunch of them. Any questions so far? Okay, is the p-value greater than, or is it less than or equal to alpha? Yeah, it's less than or equal to. So based on this, if it's less than or equal to, do you accept, fail to reject, or reject the null hypothesis? Yeah, we reject the null hypothesis. So is it significantly different or not significantly different? P-value is small. Yeah. No, you're all thinking it's significantly different if the p-value is small. We have statistically significant evidence. So the data suggests the population mean is significantly different from 23 at 0.05. So there is statistically significant evidence to conclude that the population mean miles per gallon for your car on the highway is different from 23. Okay, now the p-value. Okay, So interpret it. There is a 0.768% chance the population mean miles per gallon on your car is not equal to 23. If the population mean miles per gallon in your car is 23, and if you take another 68 trips, then there would be about a 0.768% chance that the sample mean for these 68 highway trips would either be less than 22 or greater than 24.1. Or there is a 0.768% chance of a type 1 error. Or if the population mean miles per gallon on the highway is 23, and if you take another 68 trips on the highway, then there would be a 0.768% chance the population mean would be the less than 22 or greater than 24. Which one? So 1, 2, 3, or 4. Yeah, this one's B. Okay, or 2, I guess, whatever you want to call it. Okay, so you want to get used to that, and you want to get used to writing it out too. By the way, when you're doing this on the homework, you should write it out instead of just click. And then on a test, you're going to have to write it out. You're not going to be clicking. And that way you'll get used to the writing. Okay, now let's interpret the level of significance, which is that 5%. There is a 5% chance the population miles per gallon in your car is different from 23. If the population mean miles per gallon in your car on the highway is different from 23, and if you take another 68 trips on the highway, then there would be a 5% chance that we'd end up falsely concluding the population mean miles per gallon for your car on the highway is equal to 23. Or if the population mean miles per gallon for your car on the highway is 23, and if you take another 68 trips on the highway, then there would be a 5% chance that we would end up falsely concluding the population mean miles per gallon on your car on the highway is different than 23. Or there's a 5% chance that you own an electric powered car. So none of this matters anyway. A, B, C, or D, which of the 4? Yeah, this one's C. I always try and put a little humor in. So if you said D, it might be funny, but you'll get it wrong. Any questions? Any questions on this homework problem? So be careful what you ask for, when you give me suggestions to change the class, because I will do it. So if you don't like it, you shouldn't have asked. Not that everyone asked, but a group. We're running out of time. So I don't think I can do a whole nother one because I want to talk about the project. I do let you know that another one I have done is on the discussion board for the week 7 discussion. And then you'll get to practice lots of them. So a small p-value means, no, the opposite. A small p-value means significant. We had a small p-value and it was significant. Do you see? We click significant. And by the way, 0.00768 is very small. In fact, when it's that small, you say, I am so happy I was able to show it was right. Okay. Even if it was a little less than 0.05, you're happy. If it was, say, 0.9, then it's time to give up. Then it's like, well, I'm not able to say that I was right. I'm not able to say that I was wrong, but it's not looking good. If it was, say, 0.06, then you go, oh, I'm so close, but I'm not able to say I was right. But you're so close. So what would you do then? Yeah, you do it again, but not with n equals 68. If you keep doing it with n equals 68, you'll eventually get a type 1 error. Okay, if you're wrong in the first place. So you don't keep doing it with the same sample size. Now you have to do more like 600. So you say, I'm so close, I think I'm right. But if I don't really push it, then even if I show I'm right with 68 again, that doesn't mean you're right. Because if you do it enough times, 5% of the time, you're going to be wrong. So if you do it 20 times, you're probably going to get to say you're right, even though you're wrong. Do you see? But if you increase the sample size by a huge amount, then the truth is basically always revealed. Any questions at all on that idea? Okay, one thing I'll let you know is next week, we're going to be doing this again. Almost exactly the same stuff. So if, I talked about a lot today. So next week, we're doing the same stuff. The week after that, we're doing the same stuff. Week after that, we're doing the same stuff. Or maybe that might be Thanksgiving where we do nothing. And after that, we do the same stuff. And then we have a 1 week where we do something that's slightly different called regression analysis. And then we have a final. So I'll let you know that we're spending most of the rest of the quarter on hypothesis tests. Okay, any questions on this? Okay, what I want to do, I'm going to talk about the project. But before I do that, I'm going to scroll down a lot. And we have a secret word. And the secret word is there. Why is it there? Anyone know? So the secret word is there. By the way, it's THERE. There's 3 different words of there, but it's this kind of there. And here's the reason, is that if you're doing a hypothesis test, look at the conclusion, look at the first word, there. Okay? If you even in the homework, if you look at the conclusion part, there. Okay? And that gets you going. So if you're doing a hypothesis test, that word there needs to be there. Okay? If you're doing a confidence interval, don't put the word there in. What goes there for confidence intervals? Yeah, with 95% confidence. So it's with. Okay, so you want to get that first word really helps get you going. That's why I like to emphasize it. Okay, so now what I want to talk about is the project. Okay, and I'll let you know, the project is not due until November 22nd. Okay, so it's not due before until November 22nd. By the way, what's going on November 23rd? Anyone know? Might as well tell you a couple things in the calendar coming up. November 23rd is Thanksgiving week. So we're not in class for a whole week. Okay, there's no assignments. I'm not going to be checking the discussion board all the time. My email, I don't know, I might even go backpacking for all I know. So don't expect, anything because that week is an off week. But November 22nd is not an off day. Okay, well, it might be. I recommend it to be because it's always better to turn in early. But so it's a while from now. You still have, 3.5 weeks or so. Midterm November 4th. Yeah, actually, I haven't written that out yet. Is it November 4th? Is it November 8th? Well, in this exam, was it really October 18th for everyone? Yeah, no, there were like 3 different choices. Do you remember? So November 4th, it might be. November 8th, it might be. But it'll be sometime during that week, depending on which of the, you're going to have 3 choices again. So you're going to choose one of the 3 choices. Does that sound fair? November 8th will probably be one of the choices. And maybe November 4th will be another one, and I'll look at requests too. There were like no requests last time. I said, how about these 3 times? And everyone was fine with them. And then people complained afterwards. It's like, too late. You gotta let me know because I can't read your minds. It covers all the content since the last exam. Okay. Although we do use the normal distribution for confidence intervals and hypothesis tests, but not specifically finding the probability of a normal distribution. Okay, but yeah, it's all the stuff since the last exam. Yeah, one note card, front and back, same thing. Okay, and we'll do that next week. We'll get into that. Okay, I'll do a full review next week. Okay, we have a very light section to talk about, and then so mostly it's going to be a review for the exam. Okay, but the project is due November 22nd. I know you're all thinking about the exam, but the project takes a lot of time. What's the first thing you have to make sure that you've got for the project? Partners. Strongly recommend 3 instead of 2. And there's a project 2 discussion board. Not too many people have looked at it yet, but make sure you have partners. If there's 3 of you and you're happy with each other, then you're good. Okay, if not, then you're not. Okay, and then someone in the chat box said they need one. So help that person out. Okay, so that's just a note. Now we're in project 2. Project 2 is not project 1. So I'm going to click on it. Okay, other than 3 partners. Okay, 2 is allowed. So the first thing, project 2 is all about confidence intervals and hypothesis testing. And this is why I can talk about it today, even though we don't have all the information yet. Next week we'll have more, but next week you'll be thinking about the test. So I thought today would be the better day to talk about it. Okay, so those are the 2 main things. Okay. So just a note. And by the way, just to make sure there's 3 different classes. Remember that? So if you want to communicate through the discussion board, only gets to your section. You could do it through this chat box if you want to do it, and they're not in your section. Just a warning is posting something in the discussion board only sends it to your section, and there's like legal things for that, and that's why I make that happen. But if you choose, that's your choice. Then I can't get sued. Okay. So anyway, it's about confidence intervals and hypothesis testing. Okay. So I want to let you know today there was a step 1 through step 7. Basically, that's what you're going to be doing, except there might be a step 8, and that is now do the confidence interval. Okay. So that's just a big note, and the order is important, including the way you write your paper needs to be in that order. So the order at which I did it today is how you should do it. And then after his confidence interval, you could have a little introduction, and the introduction is the idea, and there should be a conclusion. Any questions on that thought? Okay, so your project actually is going to involve something we haven't gone over yet, but I figured I'd let you know. And it's not that much different than what we did today. And that is you can do a comparison study. So something versus something. So it could be men versus women, in I don't know how many socks they own. I don't know if that's interesting, but it could be last year versus this year about something. It could be whatever it is. Unlike project 1, it does not have to be a survey of people. It could be a data collection, but what you can't do is the following. You can't just find someone else's project 2 and copy it. So if someone has already done the hypothesis test, and that someone might be the news or whatever, you can't do that. All you could do is find data. So you can collect data. That could be off the weather forecasting thing. It could be, I don't know, you could be looking online and looking at prices of your favorite food or dinner or something like that. There's all kinds of things you can do. Just like what you did though in project 1, you need to find a client. Okay, someone, and it could be fictitious, someone who'd be interested in what you're doing. Otherwise, if it's not interesting, don't do it. Any questions on that idea? The other thing with the project 2 that some people make mistakes on, if you can collect all of the data for the whole population, then you can't do it for project 2, because there's no reason to do a confidence interval or a hypothesis test if you can get the whole population. Any questions on that? So for example, if you wanted to look at the Dodgers number of runs per game versus the, now I'm blanking, who are they playing against? I'm a Dodger fan, so is it Toronto? Someone else. That wouldn't be okay, because you could get all the games for the whole season very easily. So if you could get everything, if you can get a population, then don't, then that doesn't work. Okay, and the population has to be large. So if the population is 40, then that's not okay. Okay, your sample size or sizes, depending on what you're doing. How big do you think they have to be? Not 30, over 30. Yeah. Some of you made that mistake on the project 1. 31 is okay, 30 is not okay. Okay, and I've tried to drill that into you. And if you're doing a comparison study of men versus women, that means 31 of each. You could do 35 if you felt like it, but yeah, more than 30. Any questions on that idea? Okay, it has to be quantitative, because remember, if it's not quantitative, you can't get good results without 1,000. And I don't want you to waste your time. Too much typing or too much looking. Any questions on that? Okay. You could use any sampling technique you want. Okay, you just have to admit that there's bias. So unlike project 1, what are you allowed to use for your sampling technique if you want to? What technique was absolutely not allowed in project 1? You were allowed in project 1, it's just impossible. Project 2 is impossible too. Now, cluster, you were allowed in project 1. What are you not allowed? I know it's been a week or so. No. Not seeing it, should I tell you? Yeah, convenience. In project 2, you're allowed convenience. Okay, I don't want you to spend a lot of time on the collection of the data. I want you to spend a lot of time on the analysis, and the thinking about what project you want to do. What your hypothesis is going to be. Any questions on that? Okay, you're going to do a list of the summary statistics, but the main one that you're going to spend time on is the standard error. And that'll be the standard error for the difference, not the standard error of any individual thing. It's for the difference. That's a big note. Okay, that's the main one that you want to look at. The rest are not that important. Maybe the 2 means, that might be interesting, but the standard error is the biggie. So don't spend all your time on all the rest of them. That should be a very short part of the project, but the standard error should be a big part of the project. And it should be throughout the entire paper, including when you talk about the confidence interval and when you talk about the p-value and the hypothesis test. So you can do a full interpretation of the confidence interval and a full interpretation of the hypothesis test. Okay, and then just like you did in project 1, throughout the entire paper, you need to write down what decisions the client is going to make after seeing your result for every result you've got. So when you look at the standard error, what decision will the client make after seeing the standard error? When you look at the confidence intervals lower bound, what decision will they make? The upper bound, what decision will they make? Okay, and you can also, with confidence intervals, you can explore a 95% versus a 90% and saying which is best for your client. You should explore them. It's very easy to change the number. Whereas hypothesis test, you're not allowed to change the level of significance, because that has to be done before you even start, before you do your data collection. Okay, I'm not going to read every word of this, but basically you have to interpret and talk about everything we talked about today, except it'll be for 2 variables, which we'll talk about next week. Okay, talk about assumptions that you needed. You should also talk about the repercussions of a type 1 error and type 2 error, and how you're deciding their p-value based on it. And then after you talked about type 1 and type 2 error, do that before you discuss the data. But after you look at the data and get your p-value, then you talk about which one now is the important one, just like I did today. Okay, any questions? Any questions? It's 6:31, so I'm a little over, but I knew I'd be a little over because we're talking about the project today. That's why I wasn't able to do another example of, hypothesis test for mean, because then we'd be very far over. And I want to warn you again, Wednesday, I'm not sure if I'm going to have electricity. And I want to warn you one more thing, and that is November 6th. And the unfortunate thing is November 6th is a Thursday. And that is the college's website is going to be down from 10 p.m. until 2 a.m., which means if you're a last minute person on the discussion post for Thursday, you need to not be a last minute person. You need to get there before 10 p.m. So I got an email from the college saying they're going to be down. So you may not be able to get on. Again, it's not until next week, but it'll come up fast. And I'll send some more announcements. Will I check the rough drafts again? Yes. Only again if it's done on time, Thursday morning by 8 a.m. And again, first come, first serve. So do it a little earlier is better so you can I'll get back to you faster. Okay, and similarly, you're going to post when you're ready. Just a second, on the Project 2 discussion board. What I want you to do is post your idea for your project, your H0, your H1, and in words and in symbols. And then I'll let you know if it can work. Okay, and if you do that, then that'll make a huge difference for you. If you don't, then it may not work and then you're screwed. Okay, so I'll check both your idea and I'll check your draft. Okay, this paper is usually a little shorter because there aren't the graphs. The graphs take up a lot of space. But what you do have to do is you have to copy and paste your spreadsheet data. Let me show you what the spreadsheet looks like. We'll do that next time because we're not quite ready to understand it, but at least I can show you where it is. So it's the same spreadsheet. But I'll show you the difference. Wait a second. So this basically was the project 1 part of the spreadsheet. The project 2 part of the spreadsheet, I don't think you can see it because it's at the bottom of the screen and I can't make it to be the top, but at the bottom of the screen, the tab that's open is 1 var stats. You want to click on 2 var stats. And then you'll have your first and your second column. And then depending on, you can do independent or dependent, and we'll learn about that next week. If you're doing independent, you're going to copy and paste what I just highlighted, the difference independent piece. Whereas if you're doing dependent, you're going to copy and paste this piece into your paper. And that's required. You have to do it or you lose a lot of points. Any questions at all? So I think I'm going to stop the share. I think I'm pretty much done. We're pretty far over time, which I expected to be. And I'm going to stop the recording.